Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to be going over some examples of figuring out whether or not a process is exothermic or endothermic. So remember, endothermic has to do with the system receiving heat or energy. Exothermic has to do with the system losing energy or heat. So remember, exo means out of, therm is referring to heat. So exothermic is referring to heat going out of the system. Endothermic is heat going into the system. And so if you keep that in mind, this will make figuring out what the process is when you're thinking about where's the heat or energy going. Starting with A, sweat evaporating from the skin. So here, it's the sweat is our system, right? So the sweat is evaporating. So what has to happen in order for sweat to be evaporated from the skin? Well, the sweat, which is liquid, has to absorb energy from somewhere. It has to be heated up. So that's how you get evaporation to occur. You boil something on the stove, it boils, it heats up, and it evaporates. So you need to put energy into the sweat. Well, where is that energy coming from? It's coming from the body heat. So the body heat is going to, this sweat is going to absorb the body heat, and then that's going to evaporate from the skin. And sweating is what cools you down, right? It's the evaporation of the sweat, I should say, is what's cooling you down. So, so that's going to reduce the heat or absorb the heat from the body. So this would be exothermic. So that's going to be exothermic. B, water freezing in a freezer. So again, water here is our system. The freezer is the surroundings. So the freezer is keeping things cold. How does the freezer work? The freezer works by absorbing heat from the cooling system. So the cooling system in your refrigerator uses freon gas. The gas gets heated up. It absorbs heat from the freezer and takes it away and then gets recycled, right? So that's how freezers work. So the idea of a freezer is it's going to be absorbing heat away from whatever is in the freezer. So if you put water in the freezer at a certain temperature, then the heat is going to be absorbed out of the water to make it freeze. So you go from liquid to solid by taking energy away. So in this case, oops, I made a mistake. Oops. This should be, my bad, endothermic. Endothermic. Sorry, you guys are at home are probably, what the heck? Yeah, no. So that should be endothermic because energy is going into to absorb the to evaporate the sweat. So energy is going into the sweat. So therefore, it's endothermic going into. Sorry about that. So here, energy is going out of the water. So to freeze it, energy is going out. And so this would be exothermic. So we got exothermic there. Now this one's a little bit more difficult, like wood burning in a fire. So you might think, okay, well, the fire is going into the wood, it's putting heat into the wood, and therefore it's going to be endothermic. But the reaction of burning, right? So you do need to heat up the wood to get it to start to burn. But once the reaction, the combustion reaction gets started, it produces its own heat. And then that's what keeps the fire going. So, so once all the wood is burned and there's no more fuel for the reaction to keep going, and the reaction stops and the fire burns out. So in this case, the wood burning is going to be an exothermic reaction. So the reaction of burning is going to produce more heat. And so this is going to be an exothermic thermic reaction. So that's going to be exothermic. Ice cube melting. In this case, again, to get something to melt, you have ice. So now you're going in the opposite direction of freezing. So in order to melt the ice, you need to put heat into it and it starts to melt. So the ice cube, which is our system, is absorbing the heat from the surroundings and therefore it's endothermic. So this is an endothermic process. Endothermic process. Nail polish remover evaporates. Again, very similar. It's pretty much the same thing as sweat evaporating. So anytime something evaporates, you need to put energy into it to get it to go from a liquid to a gas. So that is going to be endothermic. So that is endothermic. And then gasoline burning. Again, very similar to the wood burning. So yes, you do need to use heat or fire to get it started, but once you get it started, it takes on a life of its own. So gasoline burning, it will continue to burn until all the gasoline or the fuel is gone. So here, it is again an exothermic reaction. So this is going to be exothermic. Okay. So I hope this was helpful. I hope this clarifies what we mean by exothermic or endothermic processes or reactions. If you enjoyed this video, if you like it, please share it with your friends. Hit the notification bell so that way you can be notified by any other videos I put out. Subscribe to the channel. Make a comment in the comment section. Let me know what you think, and if you have any other questions you want me to cover or explain in another video. Thanks for joining me, and I'll see you next time.